Lesson 10-3, and this is a preview of Lesson 10-3. And in this particular activity, we will be using algebra tiles and a product math. Let's take a look at the activity number 1, okay? And before we do that, you can use algebra tiles to factor trinomials. Remember, trinomial is a polynomial with 3 terms. If a rectangle cannot be formed to represent a trinomial, then a trinomial is not factorable. So if you're using algebra tiles, and for some reason you cannot form a rectangle with those tiles, then it is not factorable. The trinomial is said to be prime. So let's take a look at activity number 1. Let's factor x squared plus 4x plus 3 using the tiles. Let's do step number 1, model the polynomial x squared plus 4x plus 3. And this is how it looks like. You have 1x squared, 4x tiles, and 3 unit tiles. Then step number 2, place the x2 tiles at the corner of the product mat. Arrange the 1 tile into a 3x3 rectangular array as shown. So this is your x tile right there, and then these are your unit tiles right there. Okay, then after that we simply complete the rectangle with the x tiles. Okay, so completing the rectangle with the x tiles, we put the 3 x tiles here, 1 x tile there, and we form a rectangle. And if you notice, it has the dimensions x plus 1 plus x plus 3. Why? Because this is considered to be x right here, and this is 1 unit as the width. This is x, and these are your 1 units. So it's x plus 3. So this particular trinomial, the rectangle, has a width of x plus 1 and a length of x plus 3. Therefore, x squared plus 4x plus 3 is equal to the quantity x plus 1 times the quantity x plus 3. Yeah, and if you want to check if your answer makes sense or not, all you need to do is simply use the FOIL method. That's a little bit of a background. We'll not do activity number 2, and we'll not do the other activities with the algebra tiles. Okay, that gives you more or less a visual, okay, on how polynomials are factored, okay, using a rectangle. Okay, let's move on to our lesson proper, 10-3. And in this lesson, you learn to solve problems by using the guess and check and to factor quadratic polynomial or trinomials. Okay, so when are we ever going to use this? When you use factoring to solve problems involving shipping and geometry. Okay, so you can use this for that. Number theory, integration. The product of 2 consecutive odd integers is 3,363. What are the numbers? So one way to find numbers is to use a problem-solving strategy called guess and check. To use this strategy, guess the answers to the problem and then guess whether the guess is correct. Wait, let me read that again. To use this strategy, guess the answer to the problem and then check whether the guess is correct. Okay? So if the first guess is incorrect, guess and check again until you find the correct answer. Often the results of one guess can help you make a better guess. Always keep an organized record of your guesses so you don't make the same guess twice. So you want to find the product of 2 consecutive odd integers. No, you want to find 2 consecutive integers whose product is 3,600 or 3,363. So we first find 2 consecutive odd integers and we make a guess. We try 41 and 43, and if we get the product of these two, it's 1,763. So that is less than what we want, 3,363. So we guess something higher, 2 consecutive integers higher than that, 61 and 63 this time. And then we get 3,843, which is now greater than what we want, 3,363. So we guess a little bit lower. We try 51 and 53, and that's 2,703, which is now still lower. So we guess a pair of consecutive odd integers higher than 51 and 53. We try 57 and 59, and voila, we have the exact answer of 3,363. And that's how you use the guess and check method to find the answers of particular problems. So in lesson 10-1, you learn that when two numbers are multiplied, each number is a factor of the product. Similarly, when two binomials are multiplied, each binomial is a factor of the product. So you can use the guess and check strategy to find factors of a trinomial. Okay, consider the binomial 5x plus 3 and 2x plus 7. You can use the FOIL method to find their product. Okay, so using the FOIL, first, outer, inner, last. Okay, first 5x times 2x, sorry, and then outer 5x times 7, inner 2x times 3, and then last would be 3 times 7. Okay, you end up with 10x squared plus 35x plus 6x plus 21, and then you add your like terms or combine like terms, you end up with 10x squared plus 41x plus 21. Okay, so the binomials 5x plus 3 and 2x plus 7 are factors of 10x squared plus 41x plus 21. Now what we want to do now is we want to find, if you are given 10x plus 41x plus 21, we want to find the factors. We want to find 5x plus 3 and 2x plus 7. And one way of doing this is what I call, okay, X marks the spot. Okay, we'll not use the method in the book because I think this is a lot easier. So let's do a little bit practice of X marks the spot. Okay, the top part of my X will represent the product of my two numbers. The bottom part will represent the sum of my two numbers. Okay, so let's start. 3 times 4 is 12. 3 plus 4 is 7. 2 times 8 is 16. 2 plus 8 is 10. So 1 plus 9 is 10. Sorry, 1 times 9 is 9. 1 plus 9 is 10. 5 times 5 is 25. 5 times 5 is 10. 6 times 9 is 54. 6 plus 9 is 15. So you more or less get the point of how X marks the spot works. Okay, and we will use this method to factor our trinomials. Bear with me here. Okay, so let's take a look at this one. The top number is the product of the two missing side numbers. The bottom number is the sum of the two missing side numbers. Find the missing side of the number. So, in what we did, we multiplied 7 times 8 to get 56, and we added 7 times 7 plus 8 will give us 15. Now, let's do the opposite. You have the product of 28, and you have a sum of 11. What two numbers will you multiply to get a product of 28 and the sum of 11? Okay, so let's use in this case, okay, using guess and check. Okay, this is actually 4 and 7. Why? Because 4 times 7 is 28. 4 plus 7 is 11. Okay, you can pause this so you more or less can do it on your own, and then simply play it when you have the answer, and check if my answer makes sense. If I make a mistake, okay, don't complain. Okay, talk about it in class. So we have 32 and 12. You want to find factors of 32, which will have the sum of 12. So in this case, it would be 32 will be 8 and 4. Because 8 times 4 is 32. 8 plus 4 is 12. In this case, 36. Factors of 36, which will have a sum of 15. That would be 3 times 12. Or 3 and 12. Okay. 48. Would be 6 and 48 would be 6 and 8. 6 times 8 is 48. 6 plus 8 is 14. Probably the only reason why it's taking a little bit time for me is because I'm doing it as I see it. I don't have the answers in front of me, so bear with me here. So I have 36 here. What are the factors of 36? We'll give you a sum of 12. Okay, hey, look at this already. It's 8 and 4. Okay, 8, nope, that's not 8 and 4. Okay, it's 6 and 6. Okay, because 6 times 6 is 38. 6 plus 6 is 12. 0. 0. Okay, would be, in this case, 3 and 4. 0 and 12. Okay, 0 times 12 is 0, 12 plus 0 is 12, 6 and 13 would be 9 and 4, 9 times 4 is 36, and 9 plus 4 is 13. Okay, and let's do some negatives. Okay, you have 36 here, and negative 37, so you have negative 1 and 36 right there, because you have negative 1. But it's a product. Also, sorry, they're both negative. Negative 1 times negative 36 would give you positive 36. Negative 1 times negative 30 plus negative 36 will give you negative 36. 35 will be 1. This would be negative 1 and 36 this time. Okay. This one would be negative 6 and 6. Okay. That's a negative 36, and the product, the sum would be 0. And this would be 28 would be, okay, 2 and 14 right here. Negative 28 and negative 16, therefore there should be negative 2 and negative 14. Okay, two negatives make a positive, the sum will be negative 16. Negative 28 would be negative 7 and positive 4, because you want to get the negative sum, and that will still give you a negative 28. And in this case now, we'll do the opposite. This becomes now 7 and negative 4. Okay, we want to get a positive sum and then still a negative 28. So this is using the X method. Now, how are we going to use this for factoring? Let's find out. Okay, but before we do that, let's do a big number here. Let's find out how to get the, let's say, the factors of 2,491 and the sum of 100 using guess and check again. Okay, and in this case, pick a pair of numbers that adds up to 100, such as 50 and 50, and write them in columns A and B. So this is 50 and that's 50. You end up with 2,500, which is higher than 2,491. We mark our check with H to signify that it's too high. Then this tells us that the number in column A is too high. So what we do next is let's adjust our guess by trying 40 and 60. Remember that guesses must add to 100. Okay, so we have 40 and 60. Now this is low. Okay, and also it is very important to note that the smaller of the two numbers must go in column A, so that there's an order in what you're doing. So we mark this as low. Then we do our next guess. Our next guess for column must be greater than 40 but less than 50 this time. So we try 45 and 55. Our new product is 2,475, which is also too low. Okay, so our fourth guess now will be 48 and 52, which will be 2,496, which is a little bit higher. Okay, now we're getting close. And now we simply try one more, which is 47 times 53, and this is the product that we want. So again, if you notice, guessing and checking works the same, especially with the method X, or the power of X, or X marks the spot, whatever you want to call it. Okay, let's move on into factoring trinomials and see how we're going to use this. We want to factor now 2x plus 9x plus 10. First things first, this is how you use the power of X. This is not in the book, so pay attention. Okay, and write this down. So first you need to multiply the first term and the last term. So the coefficient would be 2. The coefficient of your quadratic term, that's your quadratic term because it is raised to the second power. So the coefficient of your quadratic term, multiply it with your constant. 2 times 10 will be 20. Okay, and the coefficient of your linear term, which is this one, would be 9. Put it here. So we simply find two factors of 20, which will add up to 9. That will be 4 and 5. Okay, so after that, this is what you do. Okay, that means you can rename 9x into 4x plus 5x. So I'm going to rewrite 2x squared, okay, plus 9x plus 10 to become 2x squared plus 4x plus 5x plus 10. So I simply used my x method to rename 9x to 4x and 5x plus 10. So in lesson 1, we use grouping. So we will group them now. There are 4 terms, so we can use grouping. I can group 2x squared plus 4x. And I'm going to group 5x plus 10. Okay. Find the GCF of 2x squared plus 4x and factor it out. That would be 2x. If I factor out 2x, that I'll be left with x plus 2. And I factor out 5, I'll be left with x plus 2 as well. And using the distributive property, remember we talked about this in the last lesson. This is a, b, sorry, is AC. Let me undo that. Is AC plus BC, and we want to make it into, okay, we want to make it into A plus B times C. Substituting the values now, okay, you have your A, which is 2x, you have my B, which is 5, and my C, which is x plus 2. And this is the factored form of 2x squared plus 9x plus 10. Okay, let's move on to the next one. 3a squared plus 13a plus 4. So 3a plus 13a plus 4. Okay, we get the product of 3 and 3 and 4. The coefficient of your quadratic term times your constant. That'll give you 12. Okay, and then we get the coefficient of your linear term and put it underneath. We want to find the products of, or the factors of 4 and 12, which will give you a sum of 13, and that would be 1 and 12. Okay, and then we rewrite our trinomial, renaming 13a into a and 12a. So you have 3a squared plus a plus 12a plus 4. We just renamed 13a to be a plus 12a. And then we use grouping since there are 4 terms. Here now I have 3a squared plus a plus 12a plus 4. End up with, after factoring out the GCF of 3a squared and a, which is a, 3a plus 1. And then we factor out 4. This also becomes 3a plus 1. Using the distributive property like the one that we did in a, this now becomes a plus 4 times the quantity 3a plus 1. Okay? And that's a factored form of 3a squared plus 13a plus 4. Let's do letter C. In letter C, again, we multiply the coefficient of your quadratic term times the constant. Okay? And 6 times 14 would be 84. Okay? And you want to find you want to get the coefficient of your linear term, which is 25 right over here. Okay? So you want to find the factors of 84, which will have a sum of 25. And one thing that you can do is, in this case, when you're trying to guess and check, okay, you can use also your drop-down method in prime factorization. So you can use 84, drop it down to 42, 2, 21, 3, and 7. So you can use combinations of these to end up with the sum of 25. Okay. So basically this is 6 times 14, or 6 times 14 will give you 84, because 2 times 7 is 14, but 6 and 14 will not give you 25. Can do you can do 6 times 4 or 4 and 21. This is 21, and you can use these two as 4. If you notice, you end up with 21. So I can do 4 times 21 here. It will give me a sum of 25. Let me erase this. I'll have space. Okay, and I'll rewrite my trinomial using what I just got. So this becomes 6t squared plus 4t plus 21 plus 14. Using the grouping method, this becomes 6d squared plus 4t plus 21 plus 21 plus 14 21 t plus 14, I forget the t here, plus 14, and I group that as well. Factor out 2t, I end up with 3t plus 2, and I factor out 7t, or just 7, sorry. I end up with 3t plus 2. Then, use the same method, I end up with 2t plus 7 using the distributive property times 3t plus 2. Okay? And example t will be the same thing. Okay? 15y squared plus 34y plus 15. Okay? You can do that on your own. Let's take a look at the next one. We want to factor now example number 1, 10x squared minus 27x plus 18. Okay, and using the power, and using our the x method to use example number 1. Okay, we want to find factors of 180 because we want now to multiply 18 times 10, which will give us 180. And the factors will have a sum of negative 27. And we use the guess and check method. Remember, the sum should be negative 27. Okay, and we use this chart as what we did, and we find that if I use negative 15 here and negative 12 here, okay, we end up with negative 27. So this is negative 12 and negative 27, sorry, negative 15. And we rewrite this, the negative 27x through negative 12x minus the 15x. So we have now 10x squared minus 12x minus 15x plus 18. Then we group them, 10x squared minus 12x minus, okay, look carefully when I start grouping this number. Okay, remember, you're distributing the negative 1. So if you're grouping them, you're doing the opposite. So you factor out negative 1. So this becomes 15x minus 18. Okay? And then find the GCF. GCF would be 2x left with 5x minus 6. And the factor out 3. This will become 5x minus 6. Using the distributive property, you now have 2x minus 3 times the quantity 5x minus 6. And this is the factored form of 10x squared minus 27x plus 18. Okay? And let's take a look at example number 2. the area of a rectangle is a squared minus 3a minus 18 square inches. This area is increased by adding 5 inches to both the length and the width. If the dimensions of the original rectangle are represented by binomials with integral coefficients, so when you say integral coefficients, the coefficients are integers, or the number before the variables are all integers. Okay, so find the area of the new rectangle. Okay, so determine the area of the new rectangle. You must first find the dimensions of the original rectangle by factoring a squared minus 3a plus 15. So we want to find the dimensions of the original by factoring a squared minus 3a minus 18. So that means, in this case, look at this carefully. Okay, now you have a trinomial whose coefficient is 1. Okay, if the coefficient is 1, okay, there is no need for grouping. Again, let me write that down. If the coefficient, okay, of the quadratic term is 1, there is no need for grouping. What does that mean? Okay, I'll show you right now. So you have a squared minus 3a plus 18. That means 1 times negative 18, this will become negative 18 right here, and the sum would be negative 3. What are the factors of negative 18? It will give you negative 3, and that would be negative 6 and positive 3. Negative 6 times 3 is negative 18. Negative 6 plus 3 is negative 3. So that means if the coefficient is 1, there is no need for grouping. So I simply put a minus 6 and a plus 3. So you simply write what you have on your x. Okay, so that's a minus 6 was a plus 3. So the factors of a squared minus 3a minus 18, this would be a minus 6, and this should be a plus 3. Okay, so let's move on. After that, okay, after we find the dimensions of the original rectangle, okay, so the dimensions of the original rectangle are a plus 3 inches and a minus 6 inches. Therefore, the dimensions of my new rectangle will be a plus 3 plus 5 because it is increased by, if the dimensions of the original rectangle okay, the area is increased by adding 5 inches to both the length and the width. So that's why we're adding 5 here. Okay, it becomes a plus 8, and a minus 6 plus 5 becomes a minus 1. Now find the expression for the area of the new rectangle. So all we need to do is get those two binomials, and we simply multiply them using the FOIL method. So the area of our new rectangle is a squared plus 7a minus 8. Okay, fairly simple. Okay. Now, in the bottom paragraph of the book, this is exactly what I just told you about. Okay, studying a squared minus 3a minus 18 more closely. So that means in this case, all you need to do is, when you have a coefficient of 1, when your quadratic term has a coefficient of 1, you don't need to group them. Okay, after doing the x method, okay, all you need to do is write them down as your factors. So notice this is sum of 3 and negative 6. Well, that's basically what I just showed you up here. So if the coefficient is 1, after you create the x method, all you need to do is bring down the negative 6, bring down the 3, and write down the variable a, and you're done with factoring. Okay, let me give you another example of this one. Let's look at x squared minus 2x minus 63. Okay, let me give you an example of what that entails. So if you have x squared, okay, minus 2x plus 63, okay, and using the power of x, okay, 63 goes up, negative 2 goes down. Remember, the coefficient is 1, so we don't need to group. So what two factors of 63 will give you a sum of negative 2 and that would be negative 2, 9 and 5. No. 7 and 9. 7 and 9 give you negative 2. Okay. Oh, sorry. This is not possible. So I copied it incorrectly. My bad. This is actually negative 63. Okay. So that would be positive 7 and negative 9. So since the coefficient is 1, all you need to do is write down your x in quantities, and now you have plus 7 because it's positive 7, and subtract 9. That is the factored form. Very easy, right? Let me give you another example. T squared plus 14t plus 45. Again, using the power of x. 45 goes there, 14 here. So what the factors of 45 will give you a sum of 14, and that's easy enough. That's 9 and 5. And since the coefficient is 1, the factored form is t plus 9 and t plus 5. Okay? So that's an easy way of recognizing it. Okay? And let's take a look at example 3. Occasionally, the terms of a trinomial will contain a common factor. In these cases, first use the distributive property to factor out the common factor, then factor the trinomial. So in this case, if you look at this one, there's a GCF. And then there's a GCF that we need to look for. But before we do that, we need to write this in descending order. So writing this in descending order, this becomes 2t squared plus 14t minus 36. And find the GCF first, and the GCF is 2. If we factor out 2, you end up with t squared plus 7t minus 18. Okay? And then from there, you can factor t squared plus 7t minus 18, and then we know that this coefficient is 1, so we don't have to worry a lot about grouping. So that's negative 18 and 7. What two factors of negative 18 will give you a sum of 7? So that's easy enough. It's 9 and negative 2. So if you have 9 and negative 2, okay, this will now become, okay, 2 times t plus 9 and t minus 2. So that is the factored form of 14t minus 36 plus t plus 2t squared. Okay, so that's the factored form of that. I can find it here. It's not written down. There it is. Oh. Okay, so let's go to, here it is. There it is. Okay, so the factored form is 2 times t plus 9 times t minus 2. Let's go to example number 3. Oh, sorry, example number 4. A polynomial that cannot be written as a product of two binomials, of two polynomials, with integral coefficients is called a prime polynomial. So that means if we cannot find integral coefficients, which will go to our x method, then this is a prime, considered to be a prime polynomial. And let's take a look at this one. Again, we multiply the coefficient of the quadratic term times the constant. That will be 14, and this will be negative 11. And if you notice, there are no two factors of 14, which will give you a sum of negative 11. Okay, and if that's the case, this particular polynomial is 14. Sorry, 14. This particular polynomial is a prime polynomial. Okay? And the secret word for this particular lesson is spacers. The secret word is spacers. And the last example, example number 5, okay, is that we can use, example number 5 is, I think, in the next page. Yep, it is. You can use your knowledge of factoring to write polynomials can be factored using integers. So example number 5, find all values of k so that the trinomial 3x squared plus kx minus 4 can be factored using integers. So we want to find the value of k, possible values of k. So let's first do what we've been doing, get the product of the first term and the constant, negative 12, and you have k as your coefficient of your linear term. Okay, so let's find all the factors of negative 12 and we'll write it out. So one possible factor would be negative 1 and 12. Okay, we'll give you negative 12, and the sum of that one, negative 1 and 12, will be 11. So that's a possible value of k. And let's switch it around now. Let's do positive 1 and negative 12. Okay, and this will be you'll get the sum of negative 11 this time. Two more factors of 12 will give you negative 12 would be 3 and negative 4, and the sum of 3 and negative 4 will be negative 1. Okay, and you can also do negative 3 and 4. The sum now would be positive 1. Another one would be, do another color, 2 and negative 6. Possible sum would be negative 4. Okay, let me write this down on the side. And then I can also do negative 2 and 6. Sum would be 4. Let's do another color here. Let's do black one. Okay, let's do 1 and, oh, I did a 1 already. Okay, so with that, okay, the possible values of k are 11, negative 11, okay, negative 1 and 1, negative 4 and 4. Okay, and that's the end of our lesson. Thanks for watching.